Hey, good afternoon. This is Professor Gilmet, and today what I wanted to talk to you about is hypothesis testing for a mean. We have been looking a lot at proportions, and so now we're going to transition into a mean. So today we're going to be looking at a problem involving means. I'm going to pause right here and say I'm doing these videos. Oh, geez. I have not done my favorite video on Gosset and the student T distribution, but I need this video now. So this is what we're going to do today. All right. So this will be done almost exactly the same way we have done all the proportions, but we need to pay attention to a couple of tweaks. Okay. Specifically, one change is that the problem may provide the sample data. Previous to this, the number of successes was simply given, all right, and you didn't need a table of data or anything like that. But now the problem may actually contain the sample values, all right, and so let us look at a specific example of this and solve it using the steps that you are familiar with from the previous videos. Okay, and so here's our example. A psychologist specializes in treating patients suffering from anxiety disorders, all right? Pretty common in our modern society. A mix of private sessions, journaling, and medication is used to help patients function normally, and reduce stress is used to help patients function normally and reduce stress. On a survey that measures anxiety given at the beginning of every private session, the average is 55 points. All right, so behaviorists, psychologists, they have developed a number of questions, methods for determining the level of all kinds of latent variables, one being anxiety. And so the participant comes at the beginning of the session and they take this survey, and the average is 55 points. We don't know if this is good, if this is bad. This just is what it is. I am actually not a psychologist. I am a statistician. Okay, but the psychologist admits 8 new patients to the practice. Okay, but changes the medication and amount of journaling they do. So the psychologist is admitting 8 new patients, and they're making this change. Okay, and so the patients receive the following scores on their surveys. The psychologist scores them as 62, 61, 57, 60, 54, 51, 55, 52. And so looking at this, you may go, wow, that seems pretty good. Does this provide evidence that the new treatment plan is more effective? Because if it is, all the patients should then go on this new medication and change in the journaling schedule. All right. So step 0 is identify the important information. And this is really as your reading comprehension. It is really important to collect this first. It is going to really help you focus on the rest of the steps. Right? And so mu being equal to 55, that's the current average for the entire population. For her practice, for the psychologist's practice. Okay. Now we need to take the sample data and find its mean and standard deviation. All right. And so I actually did that, and I got these values. Okay. And so this is nicely done with StatCrunch, Wolfram Alpha, TI calculators. If your professor is making you do this by hand, I am so sorry. That makes me very sad. And now this is my note to say, hey, let's see how we would do it in StatCrunch. Okay, so basically what I did was I put these survey scores in. So here's my anxiety scores. Here are the 8 survey scores for those patients. And basically what I'm going to do, I'm going to move the window up just a hair so that we can see. All right, so I'm going to click on Stat. And what I'm going to do is I'm going to click on Summary Stats. And I have these all in a column, so I'm going to click on Columns. And I'm going to click on Anxiety Scores. And what I want is the mean and the standard deviation. And you'll notice it says to, do the shift-click thing. And so I'm going to do that for the standard deviation. Okay, and so now I'm going to go ahead and click Compute, which I'm hoping you can still, see on the screen. And you know what? Let's go ahead and store it. Okay, so there we go. So here we have the column was anxiety scores. The mean is 56.5, and the standard deviation is this 4.175 rounded to 3 decimal places. So it's a great, easy way to do that in StatCrunch and get the values that I got. Okay, so that's how you do it in StatCrunch. And literally, I just typed in these values right here. Okay, all right. So now, step 1, we're going to write the hypothesis. Okay, this is the same as we have done for proportions, but now we're going to use mu instead of p. So you're going to see we're going to start with our null hypothesis. It's going to be mu is equal to the 55. And what that means is the mean survey score for all patients treated for anxiety is 55. All right, so the average of every patient is going to be that. Our alternative hypothesis, our H of A, is mu is actually going to be greater than 55. I could test different from. I could. Does it make any difference? Is it worse or better? And if I was a psychologist, maybe that's what I'm wondering. But I've just done it with these small sample set, and what I'm really wanting to know is it going to improve? And so that's why the greater than there. And you can see that in do the patients receive the following scores? Does this provide evidence that it's more effective? All right, and so that's why we're using the greater than sign there. And so, of course, the mean survey score for all patients treated for anxiety is greater than 55. Okay, and so that's literally just a word meaning of this symbols right here. All right, now here is step number 2, assumptions for the student T distribution. We're not going to use the normal model. We're going to use the student T. And in a video that I will do and post before this one in the playlist, I'm going to talk about why we're going to use the student T distribution. But for this video, we're just working through an example. So we're still relying on the central limit theorem to help us get a distribution that is symmetric and unimodal. However, because we're looking at population means and sample means, we're going to use the student T distribution. And it's mainly because our sample size is very small. It's 8, and so you get fatter tails. And so we need to account for the extra values we may see in the tails. So the assumptions are very similar, but they need a slight tweak. Okay, and so independent. Is one patient's anxiety going to affect another patient's anxiety? Probably not. Is it random? It's probably closer to a convenient sample, right? Because it was the next 8. You could say it's a systematic, next 8 patients or something like that. And there are tests. If you're a psychologist and you're worried about randomness and independence, you probably have some sort of admission survey that you're giving to them to make sure that they look like the rest of the population. There are some things that you can do with a convenient sample with this type of sampling method that can ensure independence and randomness. And so what I'm going to say is the psychologist did those things and the random is met. The 10% condition. I just used the really simple 10 times n has to be less than the population. And so here we have 10 times 8 is going to be equal to 80. And that is going to be less than her number of patients that she has seen in her lifetime or will see ever in the future. And so this is going to be a big thumbs up. And so last thing we have is the sample size condition. But instead of a success-failure condition, what we're going to have is an if-then statement. If the sample is less than 15, this is the requirement. If the sample is between 16 and 29, or 39, depending on your professor, book, inclination, then you're going to need to look for something else. And then, of course, if the sample is greater than 30 or 40, depending on your book, professor, discipline, then we have this final condition, right? But ours is 8. 8 is less than 15. So the only thing I'm concerned about is that the data then does need to be very normal with no skewness or outliers. Okay? And so how am I going to do that? Well, really what I need to do is look at the histogram. And so I'm going to go back to StatCrunch, right? And what I need to do is I'm going to click on Stat. I'm going to go down to Summary Stats and Columns. and I'm going to look at my anxiety scores. And what I want to look at, here is the skewness. I'm sorry, and I'm going to store that in the data table. So there's the skewness for it. But I said histogram, and I got. So I'm going to click on the graph. I'm going to click on histogram. I'm going to click on anxiety scores. What I want to do is go ahead and put the normal distribution over it. Remember, the central limit theorem says that if I meet the assumptions, then it should look fairly much like a normal model, right? And then what I'm going to do is I'm going to go ahead and put the mean and median in, okay, for this particular distribution, all right? And then I'm going to go ahead and click compute. And remember, the reason why I put the mean and the median together in there is if they're really close together, then I don't have very much skewness. I'm pretty good to go. All right, so now let's look at this picture right here, right? It's down at the edges, it's up in the middle, there's a little gap here, but look, the median is 56 and the mean is 56.5, very close together. It does look very symmetric. And so this actually makes us very happy. I'm feeling okay about this, even though I have this very small sample size over here. The other thing is, remember I did this skewness calculation, right? And so you've got 0.063. It's very small skewness. Well, it turns out that the skewness for a normal distribution is 0, okay? And any symmetric data should have skewness near 0. And so as I look at this skewness score, this is very close to 0. My mean and my median are very close together. And so I'm feeling pretty good about the condition that the data is normal with no skewness or outliers. Maybe I should say little skewness or outliers. That's what I love about doing these things on the fly. All right, so now step 3. The calculations. We're looking for a p-value. To get the p-value, we need a t-score, because remember we're doing the student t-model. To get that, we need the t-score. And to get the t-score, we need our sample mean and standard deviation so we can determine our standard error. All right? And so our standard error for our sample means is going to be s squared over n, all inside the square root. I do this s squared inside the square root, and I don't simplify it like a lot of books do for purposes of patterns and pattern recognition. You'll remember that you have p times 1 minus p all inside the square root over n, right? And so this mimics that because p times p is p squared. Here you have kind of an s times s, which is your s squared, and it's all inside the square root. So if you have to memorize formulas and stuff, this pattern can really help you. All right. Then I simply plug in. Here's our standard deviation for our sample. I'm going to square it, divided by 8, our sample size, and I get approximately 1.476. And of course, you can do that in your calculator. And then of course, my t for the 56.5, that sample mean, is going to be my sample mean minus my population mean, all divided by the 1.476, that standard error. And so when I simplify it, I'm going to get 1.016 as my t-score. All right, and so if I plug that into the t-score calculator, the t-calculator, I'm going to get this p-value right here. But I actually want to show this to you. So I'm going to switch over to StatCrunch again real quick. And so I'm going to make sure you can see it. Stat, calculator, t, okay, so the t calculator. I warned my students earlier in the semester that they should get used to doing the t-score calculation because you can't actually change the mean and standard deviation in the t calculator in StatCrunch. You also can't do it on the TI calculator. So you do actually have to put the t-score in here and the degrees of freedom. Now we've previously stated that degrees of freedom are 7. And the values we are looking for are greater than, and we're looking for greater than 1.016. And I got that from right here, 1.016. And I'm going to plug that into my calculator and hit compute, and that's going to give me a p-value of about 17%. Okay? So about 17% of samples are going to be this far away or further. And you can see this is quite a bit of the student t distribution. Okay? So we can see our p-value is quite large compared to most levels of significance. Now, I'd actually like to just do it in StatCrunch, the hypothesis test with all the calculations. It's pretty sweet. So if I actually go here and I click Stat and I go down to T-Stats, I actually have one sample with data. And my data is in the anxiety scores. And my hypothesis that I'm testing is that it's 55. And my alternative hypothesis that I'm testing is that it's greater than. And so with the data, it will actually calculate the mean, the standard deviation, then the standard error, the t-score, and do everything all at once. So all I have to do is click compute, and I will see here is my null hypothesis, here's my alternative hypothesis, here's my sample mean and standard error, right? And so with my degrees of freedom, here's my t-stat, and here's my p-value. Those are all exactly what I got when I did the hand calculation. So this is a super nice tool, okay? So there it is in StatCrunch. So now it's time for the... Oh, wait, too far down. So this is time for the conclusion, right? Step 4, conclusion. So now we're just ready to state our conclusion. With a level of significance of 5%, we've failed to reject that the mean survey score for patients treated for anxiety is 55. We do not actually have strong evidence that the mean survey score for patients being treated for anxiety is greater than 55, with a p-value of 0.1717. Now, this is a case where we're probably not going to do any harm because the patients already have anxiety and we're trying to reduce it and we're intervening in that way. But maybe we don't want to reject what might be a better treatment because our criteria was too high. Our level of significance was too low. So we might change this to 10%. Okay? Now, even if we do, we're still going to fail to reject. But this might be a case where maybe a 10% level of significance where the benefit outweighs the potential harm is actually a good one. And this means that the new treatment plan of medication and journaling is not working any better than the old treatment plan. From this sample, it is also not working any worse, right? So that's kind of an interesting thing to note. So maybe a larger sample, instead of using 8 patients, maybe if she did it with 20 patients, maybe it's simply a dosage or other adjustment in the journaling might be in order. One of the things that I did on purpose, and I hope people were thinking about this in the back of their head, is I adjusted the medication and the journaling. And really what I should have done was change the medication, seen the difference, and change the journaling, and then seen the difference. But sometimes we have reason to believe that the medication and journaling co-varying together are going to give more of an improvement, but it makes the stats a little more difficult and higher level. Okay? So this is it. This makes us very happy. We're at the end. We have our conclusion. It really is just a few tweaks from the proportions. If you like this video, please subscribe to my channel and watch all of them in the playlist.